So really we only have two members left to find. So let's look at the forces at D. And because let's look at vertical situation. These both have to be pushing upward to compensate for this downward push by the load, which means these are in compression, okay? They're being compressed and they have to push upward. By the way, let's go ahead. Since these have to be the same, let's do the rest of the week. So we know everything except this one we've talked about. Okay, so let's do the y equation. Negative 1,000 for the load, and let's look. These are compression; they have to be upward. Let's look at what that's going to look like. It's going to look like that. Let's do this one first. The components are like this. This is 60 degrees, so I'm going to move this over here to get a triangle. And this is, we're going to call it FDC. So this component here is positive, is pushing up, plus FDC sine 60 degrees. And plus, and I'm just going to do it 2 because we know it has to be the same as the other one. And that's going to be equal to 0. So you get FDC equals 1,000, moving that to the other side, and dividing by 2 sine 60 degrees. And that's going to be 1,000 divided by 2 divided by sine 60 degrees. 577.35. 577 pounds. Okay. Store that in C. All right. So FDC, and that's also equal to FDE, equal 577 pounds. All right. We only have one more member to find, and that's this one. It would be a little tougher if we didn't have such symmetry. For instance, we couldn't assume that these two were the same, and we might end up with having two equations and two unknowns. But for this problem, we should stick with the problem as it's stated. The y equation is not going to tell us anything new because this one's not part of it, so we just have the x equation for this. And so let's get rid of that. And look what we know over here. Okay, so we've got several forces. Let's just take this one at C. We've got 1, 2, 3, 4, 5 contributions. So no, just 4. The vertical load doesn't contribute. We're just trying to find this now. So we have negative FAC, right? Plus FCE, and then we're going to have 2 contributions. Let's look at this one first. FBC. FBC is going to do what? Well, it's tension, so it's pulling upward at that angle. And so here's 60 degrees, and this is FBC. Now I'm going to move this over so we get a triangle there. So we have, we're interested in the y. Are we doing the y? No, we're doing the x. I'm sorry. Let's just erase this for right now. This is x. FAC is tension. It's pulling that way. FCE Actually, we're not sure yet what whether this is tension or compression. Turns out that if you just put it in as positive, if it's which would say that it's in tension. If it's not, it'll come out negative. Okay, but let's just hold off on that. Maybe we'll be able to tell if it's compression or tension. Let's see which way. This is pushing it that way. This is pushing it that way. This is pushing that way. No, this is also tension here. So all three of these are pulling it that way. This must be in tension also. It's the only one that can counteract those forces. So all the bottom ones are in tension. So anyway, so that's going to mean, but tension means that way, so that's positive for this joint, forces that way. So then we've got two more. So minus, because it's that way, minus FBC cosine 60 degrees. And then the other one is also, it's downward. And it's this one. This is 60 degrees. And this is FCD. So minus FCD cosine 60 degrees equals 0. Okay? So what we're trying to find is FCE. Let's leave it on that side. So we got FCE equals FAC plus FBC cosine 60 degrees. Why don't we lump these together? Plus FBC plus FCD times cosine 60 degrees. And that's going to equal, hopefully, the correct one, which is, okay, so FAC is 1443.37, 0.38 actually, plus parentheses FBC, FCD, what's FCD? I've got an FBC, okay, plus 2887, that's FBC, plus 0.75, just accuracy, plus 577.35, plus 577.35, all times cosine 60 degrees. Okay, 3175. 93, so 3176 pounds. Hopefully that's what it. Yeah. Okay. So anyway, so now we've got all of them. FCE. You can see it's the most got the most force in it. And it's in tension. Okay, so now we basically have the whole problem. Because we know the rest, they're going to be the same as their counterpart on the other side. So FEG is going to be the same as FAC, which is 1443 pounds. In tension, FG is going to be the same as FAB, which is 2887 pounds. Okay?